Welcome to Altium. My name is Chris Carlson, and I'm one of the technical marketing engineers here at Altium. Today's presentation, Designing with Assembly Variants, is brought to you by the Altium Academy. Okay, so today we're going to first discuss what an assembly variant is and what they're used for. Then I'll be showing you the variant manager and its features. Then we'll cover creating and editing variants. Then we'll go through displaying variants and how to set that up for your various design documents. Then I'll go through a quick little demonstration, then I'll open it up for Q&A. Okay, so when a product needs to be designed and produced with several variations to the base design, where each has different options or capabilities, the ability to implement variants avoids the need to create a separate design for each of those variants. In practice, a design variant uses the same base PCB fab, but the PCB is loaded with a different set of components specified by the variation. Then that particular variation can be nominated when you're generating your manufacturing outputs for your bill of materials, pick and place, assembly drawings, etc., which in turn will determine how the product is assembled. The ability to create variants of the base design adds some pretty significant flexibility to how PCB projects are created in Altium Designer. When using variants, you can define any number of variations to the board design where each component may be configured as fitted to the board, not fitted to the board, a completely different component, and each variant can also pass parameters down through the entire project. So you can rename the schematics to indicate what the variant is and so on, and I'll show you how that works. Design variants that use any of these type of variations to the assembly are referred to as assembly variants, as they only impact the assembly process. In this case, all variants will share the same PCB fab at the end of the day. Okay, so PCB variants allow options when procuring components. So for example, in the graphic being displayed, it shows both an SOIC and a BGA option for a memory device. If the two footprints are both part of the same varied component, they will have the same reference designator, and the tool will allow you to stack them on top of each other. So the purpose of this is to give procurement more options when loading components for the build. All right, this is the variant manager. It's a modal dialog which allows for the creation, editing, and configuration of the visualization settings of the assembly variants. The upper left region displays the components in their original base version. Then to the right of that, you'll see each assembly variant as we create them, and component line item shows the status of not fitted or alternate component. If it's the same component, nothing is displayed there. The lower region shows a selected component, and it shows the base version to the left and the details of the component for each of the assembly variants to the right. And the controls for the variant manager then are along the bottom of the dialog. To add an assembly variant, simply click the Add Variant button, and you'll notice that's a little drop down there. There's also, if you already have a variant, there's an option to clone a variant, and so you just hit the little drop down and choose the other option. It's also at this stage where you can add parameters to the variant, which will flow downhill through the entire project. And again, I'll show you how that works as we go along. Now, once the new assembly variant has been created, the component actions are applied to the left of the selected component. The Browse button will pop up a dialog allowing you to choose the fitting and alternate part actions. The variant options modal dialog is opened by clicking on the drawing style button. The dialog is divided into two regions. The upper region is for schematic drawing options, and the lower section is for the classic assembly drawing options. Now, we won't be using this, as I'll be working with a Draftsman assembly drawing, and it has its own controls there in terms of how things are displayed. Various parts of the drawing objects may be crossed out or a mesh box applied to the non-fitted components. And you can also use text such as DNL for do not load, or however else you want to configure that. Alternate components may have a font change in the component parameters, such as the comment or value fields. Okay, let's have a look at this. All right, now you're looking at the current public build of Altium Designer, and I have the NBP28. This is one of the daughter cards for our nanoboard product. And so I've got a top level schematic here. This is a hierarchical design. In this design, there is an FPGA as well as a processor, and the processor has its memory devices, and the FPGA also has some external memory as well. What I want to create is an assembly variant where we leave the FPGA memory off. So this would be for like a lower cost version of the product. So to open the variant manager, top toolbar variants. Now again, here you can see all of the components in the design, and as I select a component, all of its information is displayed here at the bottom. So I've got the various parametrics of the part and their values. I'm going to go ahead and click Add Variant, but you'll remember I mentioned it's grayed out now because I don't currently have a variant in the design, but if I had one, I could click this Clone Selected Variant. So I'll go ahead and add a variant, and I'm going to call this No FPGA RAM. Okay, now I'm going to allow this to affect my fabrication outputs. That's something you'll always want to do. And I'm going to add a couple of parameters here. So what I want to do is I want to change the title in the title block. So I'm going to add that parameter. It's actually called title. And I'm going to call this NBP28 No FPGA RAM. And so that's for my schematics. Then my Draftsman assembly drawing has a couple of lines for the title in its title block. And the one I'm going to want to vary is actually called PCB Title 2, and I'm going to give it the same nomenclature. NBP28 No FPGA RAM. Okay. So in this case, what we're going to want to do is leave the two memory chips and their bypass capacitors off the board. So it looks like we want to remove C49 through 58. And if you go in here to the designator, you can actually type and it'll filter for you, just to get you there more quickly. And what was it? It was 58. So we'll grab those, and I'll right click here. I don't want to do each one individually. Give me a second here. 58. You got to be careful where you click in here, because when I right mouse click, sometimes it removes the selection. So I'll set those to not fitted. So we've got 49 through 58 not fitted. Then we'll come down here to, I think it's U3 and 4. Yes. U3. And this time, since I've only got 2 of them, I'll hit the little browse button here. So you can see the little dialog that pops up. I'll set that to not fitted, and I will set this to not fitted as well. Okay, now when we look at our drawing style, I'm going to click the little drawing style button here. In the upper portion, we have our schematic drawing style. Now, I can put a big X on the non-fitted components, or I can use a mesh box. I don't have to use a graphic. I could just use some text, such as do not load, and or I could use nothing. I'm going to use a mesh box and the text do not load. And then if I have an alternate component, let's say I've got a different filter value on one of my variants, you can put a suffix in here. So you can suffix the parameters, or you can just change the font. In this case, the default is changes it to green italicized, and I'm just going to go ahead and leave that. Now, the PCB drawing options, this is for the classic fabrication and assembly drawings that you make in Altium Designer pre-Draftsman. So back in the day, you would create a sheet of paper and then you'd start stacking up mechanical and copper layers and so on. And this is the drawing style for that, but we won't be using that today. I'm going to actually be showing you Draftsman. So I'll click OK and OK. Now, you'll notice I've got two variations here now under the variants directory of my project. I've got no variations, and then I've got no FPGA RAM. And you'll notice my title has changed as we would expect it to. And we can view the non-fitted components here. Now, there are two tabs here at the bottom of the workspace. The editor version is what we refer to as logical. That's the schematic you draw. And the tab just to the right of that is the physical. This is what actually gets loaded on the board. If this were a multi-channel design, you'd see tabs for each of those channels. And as I click on them, you would see their various reference designators and so on. So when I'm looking at a variant schematic, I can see some of my parts are do not load. All right, so let's open the PCB and have a look at this there. Okay, I'm going to go into the 3D view. And now when I select the no FPGA RAM, you'll notice the RAM chips are no longer populated, and neither are my bypass caps. If I flip this over, I've got a few bypass caps on this side which are not loaded as well. Okay, now I'm going to open my assembly drawing. This will take a few seconds. This assembly drawing was obviously created before we ever had a variant, so we'll have to update the variant information. Now, I've got some drawing styles here. I can use a mesh box, or I can just hide the components. Actually, let me bring the variant in and show you that, because it'll make more sense. Now, you'll notice, oh, my no FPGA is there. Cool. Okay. Sometimes you'll have to pull the design in after that, but that's cool. Now, when I do this, it will pull the data in from the PCB. When you do this in a Draftsman document, it's a similar methodology to updating a board from a schematic. You don't want that to happen, just real time. You want to be able to pull the trigger on that. Well, this is the same way. So this will go ahead and pull updated information from the board, and this will take a few seconds to finish as it's bringing in all of my various assembly views and other information. Okay, so you'll notice down here I've got my MBB28, no FPGA RAM, and I have my components highlighted with a little mesh box for those that aren't fitted, and I did add a line item in that for my notes to call that out. Now, one of the things you can do is you can change how these things are displayed, so I could hide the components. Now, I don't like this as well, because when the assembly house is looking at the drawing, they might miss that they're not seeing a component there. I like to actually have them see the components with the mesh box indicating, hey, these are do not load components. You've got some options in here for the color and the pattern You can make it solid. You can use a couple of different ANSI standards here. I have to hit the dot, dot, dot button again. And I like the little mesh box. This is just single hashes, but I think it's the 37. Yeah, it's kind of the hashed pattern there. Okay, now I've got another project, and I kept this very simple so you could see specifically how this works. So I've got a RAM chip here, and I have the various nets associated to this with reference designators. And in my variant for this, where's my variant manager? I've selected a different component. So here I have the base component and a varied component. And the difference is, this is like the example that you saw in the graphic in the slide presentation. The package for the base variant is a TSSOP, whereas the varied component is a BGA. And again, this is useful for giving procurement purchasing options. Okay. Now, okay, so let's look at the board. Now, I'm going to bring the design into the board. So I'll import the changes, and we'll go ahead and execute that. And you'll notice that it will bring both footprints in. So I can place both of these. Let's flip that around, get it, let's see, get the right one selected here, and I want to turn off the other reference designator. So what we can do is we can go ahead and fan both of these out, and then you can go ahead and start performing the routing between them, and get that all set up the way you like, and then you can treat this as a single component and then just route to the outside TSSOP package footprints. And for completeness, if we look at this in 3D and look at the two variations, there's my BGA and there's my TSSOP. All right, so I'm going to go ahead and open it up for questions. Next week, Alex Tamari is going to present another webinar on this topic, and he will cover how all of the data flows downhill into your manufacturing outputs, your bill of materials, how to configure an output job file, and all of that kind of stuff. So, you have any questions? All right, well, I'd like to thank you for your time today, and as always, have a really great week.